Certificate Authorities, Part 1. In this nugget, we take a look at certificate authorities, and a certificate authority is just a part of a public key infrastructure, and there are many different uses for that. You can use it to authenticate email. You can use it for encrypting of various kinds of files, for web access, and we'll see the various kinds of uses for a public key infrastructure. Now, when they have a certificate authority, it's going to issue certificates and accompanying keys along with those certificates, because the certificate is kind of just a container for the keys. And then we'll see how those certificates works and how those key works. Then we'll take a look at various types of CAs. You might have standalone CAs, enterprise CAs, internal, external CAs, several different kinds of CAs that you need to consider when you build up your PKI infrastructure. And then that PKI infrastructure is going to be tiered in most cases, so we'll take a look at the hierarchy that's going to be involved in there, as well as how to protect the certificate authorities, because they are going to be crucially important in terms of high priority security servers that you do not want to have compromised in any way. You might recall from a few nuggets ago that I showed a picture of a scorpion on the screen here, and I'm sure you were quite taken aback by this picture of the scorpion that had invaded our house not long after we moved into our new house a few years ago. Well, I was out doing some errands this weekend, and I get a call on my cell phone from my wife complaining hysterically that she had once again seen a scorpion. She came around the corner of our house. There's another scorpion, rears its ugly head again, and so here we are back with this same guy again. Of course, I'm sure it's not the same one from before, because after all, we did kill that one. Anyway, so we get this scorpion action going on again, and what she did was she took a trophy off of the shelf. She's a cheer coach, and they win some competitions and stuff like that. So anyway, she takes this trophy, and she smashes the scorpion. Only the thing is, it just kind of flattens itself, gets back up, and starts to crawl away again, and they crawl really fast. So she smashes it again with this big, heavy trophy. No effect. I guess it's that exoskeleton, if you look at it. These scorpions actually have the skeleton on the outside of their body, and instead of on the inside of their body like we do, and it makes them very resilient to smashing and stuff like that. And she only had sandals on, so she didn't want to step on it for fear that it would get that wicked tail around to the edge of her shoe, her sandal, and sting her. So finally, she keeps smashing and smashing until, after, I think, nearly breaking that trophy, she smashes it about 10 times before she starts making some progress. Well, you know, it's kind of like what we have within encryption and decryption within a computing environment. Well, it's like that with encryption as well. I mean, giving enough brute force power, you can use computing power and a little bit of programming knowledge to decrypt certain kinds of files or decrypt certain kinds of data. Probably the best protection we have against that kind of a security exploit, however, is going to be with a PKI, or a public key infrastructure. And this uses a public key and a private key to be able to do a lot of different things for us. And let's take a look at what some of those kinds of things are. Well, let's take a look at some of the PKI uses that we can implement here. First of all, we can use it for signatures. Now, a PKI uses a public key and a private key. In a typical scenario, a user will have a private key which must be closely guarded and which you should not give away or send off to somebody in an email. You should protect that carefully. On the other hand, the public key is something that's available to just about anybody, and you already have several public keys already on your computer, which are already installed by default with Windows, such as ones from Thought or ones from VeriSign and all different other kinds of organizations. Anyway, as far as the signatures are concerned, it's the private key that assigns something, or signs something. So you can use it to sign software, for example. So if I download something like the QuickTime Player from Apple, or if I go to, I think I got a bookmark for it here, Macromedia, and I try to get the Flash Player, and then I get this little security warning dialog box from within the browser that says, hey, do you want to install and run such and such a software distributed by this company, and just verifying whether or not I want to be able to do this. Now, this looks all very official, and it is a good message to see, because I want to make sure that I am getting the software from who I think I'm getting it from, and that's what a signature does. It performs non-repudiation, which means that Macromedia cannot possibly deny that they sent this to me, because if I click on this, I can see that in the certification path, it was indeed issued to Macromedia, and there's really no way, yet at least, to counter that, or no way to spoof that or fake it. And if someone has attempted to tamper with this, then it would not say this certificate is okay down here at the bottom. So we see here also that there's a chain of trust that goes on. This was issued originally by VeriSign, and they issued it to an issuing CA of some kind right here within their own company as well. So we have, you'll see later on, we'll have different tiers of issuers that we have within a CA. And then we have this one directly from Macromedia Inc., and they have purchased the ability to generate certificates from VeriSign. That's how they were able to do this. Now let's go back to our original dialog box here as well, by the way. This also doesn't mean that this is good software. I mean, it is good software for Macromedia. But you can get this if you go to a number of different sites, and sometimes you'll get this message and it pretty much just invites you to download a bunch of crapware. My kids, when they browse on the internet upstairs in their little room, makes it sound like I have them locked in there or something like that. Really, it's more of a closet. Anyway, when I have them locked up there, what they'll do is they'll browse and they'll get to this website, and it gives you this Gator thing, which is this adware stuff. And I keep telling them, don't click on yes, but nevertheless, they click on it. And then we've got that whole machine infected with all kinds of pop-ups and adware and that kind of stuff. So this doesn't mean it's any good. It just means that it does come from who it says it came from. And then you'd click on yes, and that gives it permission then, provided you have administrator responsibilities on this machine, then it gives it that ability to install that software. And by the way, to prevent my kids from ever doing that again, I did a couple things. I don't let them be administrators on the machine that they installed up there anymore. And I also set up a spyware, adware blocker up there that prevents that kind of thing from happening anymore. And then when it's done, we see the installation is complete, and we can enjoy all kinds of snazzy graphics here and stuff. All right, what else can we use a signature for? Well, we can use a private key to sign email, which confirms that it did indeed come from us. In fact, depending on the project, when I have Microsoft contracts, I will have to sign my email to make sure that my message was not tampered with in transit. And sometimes you'll have to encrypt the email as well if there's sensitive data that's included with that email as well. With Internet, we can control things such as who accesses that certain Internet web page. For example, if I've got a finance division within my organization, I have a finance intranet web server, and I can confirm that only people with the appropriate certificates are able to access that internet web page. We also have encryption. Microsoft has EFS encryption available, and you can encrypt certain files, and once you've encrypted them, only your private key will be able to decrypt them. And there's also a data recovery agent, which is some kind of an administrator that can also, as a failover, also decrypt messages or decrypt files. But without using one of those two methods, either the DRA, data recovery agent, or the user's own private key, you're not going to decrypt those files. In fact, they'll be gone for good. In fact, somebody I'm familiar with, a lady who's a security expert, had a man come up to her at a conference not long ago, and he said, "Hey, I own my own company. We're very successful. We make a good dollar, but I had to reinstall my laptop the other day because of the operating system problems. And then when I tried to decrypt some files that I had encrypted earlier, which are critical to a very large dollar deal that we have going on, when I tried to decrypt those files, I couldn't open them. What's wrong?" She says, "Well, when you reinstalled your operating system, you generated a new key pair," which he didn't understand what she was saying, but he generated a new key pair, "and then you were not able to decrypt those files." He said, "What should I do? My company depends on those files." She said, "Declare bankruptcy." Because you're not getting those files back, my friend. Once they've been encrypted, if you don't have the appropriate keys to decrypt them, Microsoft's EFS is just about as uncrackable as anything's going to be. So be real careful with that usage of it, although it's very effective. Smart card logons, which gives us two-factor authentication, something I possess, which is the smart card, and something I know, which is a PIN. Very good use of certificates once again. And then we also have IPsec so that we can protect and encrypt our data in transit, whether it's over wired or wireless networks. And before we get too much further into this, we'll probably ought to take a look at how keys actually work. You can use a symmetric key or a public key infrastructure. The symmetric key simply means that you use the same key to encrypt the data as you do to decrypt the data, in terms of encryption at least. So if I have a key here, see if I can make one. Looks something like that. I don't know really what that is. It's supposed to be a key. Anyway, there's a key here, and I'm going to use it to encrypt maybe some plain text. Maybe it's even just a notepad file or a Word file or something like that. And then I use that to encrypt this plain text so that it then becomes encrypted. Well, then I can use the same key or a copy of that same key to decrypt that encrypted data. So now if I take that key or a copy of that same key and I apply it against this encrypted data, it then reverts it back to its plain text. Now the thing there is, it's the symmetric key that is a security issue here, because if I encrypt it with my symmetric key right here, and I want my friend somewhere else to be able to decrypt that same encrypted data now that I have encrypted, how does my friend decrypt it? Well, I have to get him this key somehow. And what I can do is maybe send it to him in an email. Well, what if somebody intercepts the email and they get the same symmetric key? Or if I send it to him on a floppy, and somebody else in the same company picks up that floppy and also gets that symmetric key. So there's just a number of ways of compromising that symmetric key. And the other part of that is, if I have a project where I'm involving hundreds or even thousands of different people that also have to be able to read the data, well, then I have to disseminate that key all those different times, and it gets to be extremely impractical. And by the way, just in case you were wondering, when I say plain text, that doesn't have to mean like a notepad file. Plain text in encryption is just another way of saying something that's not encrypted. It could be a database file. It could be a picture. It could be just about anything. It's just if it's unencrypted, then it's considered to be in plain text. Now, just as a side note, by the way, as well, when you use EFS encryption against a file with Microsoft Windows products, it actually encrypts it using a symmetric key. But then it takes this symmetric key, which would otherwise be pretty insecure, and it can use a public key infrastructure against it, because it takes this key and then it will encrypt it. And this is known as the file encryption key, by the way, in EFS. It encrypts it using the public key, and then the key itself becomes obfuscated or impossible to access, because unless you have the private key that can decrypt this now encrypted file encryption key, then you won't be able to access that symmetric key to be able to decrypt the data. So we would have to have either the user's private key, or we'd have to have a data recovery agent, which is configurable within policies, to be able to assign certain people the ability to decrypt this file encryption key. So then anything that I sign or encrypt with the private key in a PKI infrastructure can only be viewed or decrypted with the public key. Conversely, anything that I encrypt with the public key can only be decrypted with the private key. And this is the beauty of what the PKI is, what the certificate authority can do for us, because this prevents me from having to take the same symmetric key and send it around to all these different people, even hundreds or thousands of different people, and be concerned about the security of interception. Instead, in a Microsoft CA, I can have a public key that already exists on my certificate authority, and I can disseminate that public key whenever I issue certificates to all of my users or my computers. And then those users or computers will also generate or receive their own private key as well, and I don't have to manually issue that key to all of those users or computers. I can do it manually if I want, and it would be much more secure than sending around the same key, because with a private key infrastructure, each key is globally unique. So even if one of the private keys were to become compromised, it wouldn't bring down the entire organization in many cases. And whereas if this symmetric key is compromised, then all the people that possess that symmetric key would then have to find a different key, or we'd have to start something over again in our security infrastructure. Now, I've talked about certificate authorities and PKI and certificates and keys and all of that kind of thing. Let's get a little bit more definition for how that process actually works. You see, here we'll start with a certificate authority. And there are several different kinds of CAs, but we'll just generally say this is a certificate authority. And its job is going to be to issue certificates. Now, along with those certificates will be an accompanying public key. And the public key identifies the certificate authority from which the certificate originated. And then when I have let's say a computer down here that needs to request a certificate, and that request is granted, and we'll see how to do that as well later on, then the computer will receive the certificate down from the CA, and in addition to that certificate itself, it'll also receive a private key for that computer, and it will be stored on the computer. Likewise, when a user requests a certificate, then what happens here is they also receive the certificate, but they have a user's private key that will also be stored on the computer. And that private key may follow the user around from computer to computer if they have something like roaming profiles, because the key is going to be stored within a user's roaming profile. If we use Microsoft implementations, such as if we use roaming profiles, and if we use certificates that are associated with Active Directory. Now, first of all, let's take a look at the standalone CA. Now, a standalone CA, first of all, does not have any dependence or integration with Active Directory. Any requests that are submitted, therefore, have to be manually submitted, and the user that submits the request has to supply all of the information, such as the user's name, their email address, any of that kind of information. And then, once it's submitted, it becomes a pending request, and an administrator has to manually approve of and issue a certificate or reject the certificate request. Now, with a standalone CA, there are no certificate templates, so there's no customization of the templates in terms of what their purposes are and things like this. So we just have to use whatever comes out of the box, and for most purposes, that's still okay, so don't despair of that quite yet. Then if you want some customization of those certificate templates, we'll see that with Enterprise CA in a little while, we can do that. Now, also with a standalone CA, when you install a certificate from a standalone CA, especially if it's from a subordinate CA or something further down a certificate hierarchy, then you're going to have to put a certificate in the trusted root, and you have to do that manually. There's no automation for that to happen. So for the end users, that can be a little bit involved. For an administrator even, sometimes it can be a little bit involved. So a standalone CA requires a lot more manual interaction, and you can see that through these steps here. Now, what good is a standalone CA? Well, frequently we will put those in the role of a root certificate authority, or standalone root CA. And then a standalone CA can also be used as a subordinate CA, or we also will call that, in certain instances, an intermediate CA. Now, a subordinate CA is just any CA that's not the root. So that can be 2 levels deep, 3 levels deep, however many levels deep you need to go in your PKI infrastructure. And we'll take a look at a little bit more of that when we look at the PKI hierarchy. You can also use it for extranet purposes. Now, if I have business dealings with another company and we need to exchange some secure information, or we need to be able to authenticate one another's identity, well, this other company is not my company, so it's not going to be part of my own Active Directory. So I'm going to have to figure out another way to authenticate that they are who they say they are, and that they can do mutual authentication and identify that I am who I say I am. Anytime we do things like exchanging email or use an IPsec connection that's confirmed with certificates and that kind of thing. So that's another purpose for a standalone CA. Now, an enterprise CA has Active Directory integration. In fact, Active Directory is required for an enterprise CA. Now, when it comes down to the issue of enrolling users or computers with certificates, this is where things get real easy with an enterprise CA, because there's very little manual involvement that takes place. In fact, all of their manual involvement really comes in setting this up. Once it's properly set up, you pretty much don't have to do anything, and it just kind of does it by itself through auto-enrollment. And you can auto-enroll computer certificates as well as user certificates. And those user certificates can also be very useful on smart cards, which is another good use of an enterprise CA. Now, because an enterprise CA is Active Directory integrated, then we can take users' private certificates, or private keys that is, and put them on the smart cards. Now, if they did not have Active Directory integration, we would not be able to use smart cards, because we would not be able to associate a certificate or a key with a specific user account in Active Directory. That's why it's not available in standalone. It's only available with an enterprise CA. Also, in Active Directory, it's going to publish certificates that the users have enrolled. It's going to publish the CRIL, or the certificate revocation list. It's going to publish that to Active Directory. And this is going to make it very useful in terms of how accessible it is. As long as you can access a domain controller, you can access the CRIL. As long as you can access a domain controller, you can access any of the certs that have been issued. Now, this may have an impact in terms of the size of Active Directory, because if you've issued thousands of certificates, well, then the size of Active Directory is going to grow correspondingly. Then we also have certificate type 2 templates here. Now, this is in contrast to the standalone CA, and it's also in contrast to Windows 2000, because Windows 2000 had type 1 certificate templates, not type 2. Type 2 certificate templates allow you to edit and modify the purposes and use of various kinds of certificate. And then anytime a request is made for a certificate, all that information can be automatically supplied in the auto-enrollment process, because since it's integrated with Active Directory, it can just pull that information right out of the user's account, what their email address, what their name is, maybe even any of the other information that's necessary to enroll that user with a certificate. Now, besides the decision of whether or not to use an enterprise CA or a standalone CA is the additional decision of whether or not to use an external certificate authority, which is a publicly available commercial CA, such as one from Thought or VeriSign or something like that, or whether to use an internal CA, which I install myself on my own Windows Server 2003 server. Now, with an external CA, what are the purposes of that? Well, that's pretty much for public use. That's when I have a resource available that I want the internet public to be able to access, such as with Macromedia's software that they installed. Well, they used an external CA for that. They used a VeriSign certificate authority to issue the certificates. Because if they didn't do that and they didn't make it available for public use in that fashion, what else are they going to do? Well, they could set up a website and then they could give people instructions on how to download the certificate from one of their internal CAs, how to install it, and all that kind of stuff. Well, I don't know about you, but I don't think any of my users could figure out how to do that or actually follow the instructions verbatim and actually successfully install their certificates. So that would be a disaster in terms of them trying to deploy their software because very few people would probably do it right. So that's one reason why we have a publicly used certificate authority with products like that, because the root certificates are already installed on users' computers for VeriSign and Thought and all those other common companies. Now those are, again, the external CAs are going to be from third parties such as those that I just mentioned. And the other thing about them is they're commonly trusted. I mean, if you see a certificate from VeriSign, generally speaking, you look at it and you say, yeah, I think I can trust that that is a good certificate. And in addition to the fact that many of those certificates, especially from trusted root CAs, are already installed on most Windows machines. For example, let's just get off of the whiteboards for a minute and go here to Internet Explorer, where we can see that in the Tools and Internet Options menu item here, we have a Content tab where we have a Certificates button, and we can view the certificates here. We can also see the certificates if you custom build an MMC console, which I'll show you how to do after a little while here. Anyway, we click on Certificates and go to Trusted Root CAs, and here we see all the different worldwide CAs that are available from Thought, VeriSign, Baltimore, Deutsche Telekom, Equifax, GTE, Microsoft, all these different ones that are available to us. And the fact that these are here now will indicate that any certificates we receive or that we encounter that have been issued by one of these trusted root CAs, we will automatically trust it through a chain of trust. So anyway, that's where we can access some of those kinds of certificates that have already been installed, how we can confirm that. We also have administration in an external CA that's going to be much lighter than if we have an internal CA, because face it, somebody else is doing all that administration for Thought and for VeriSign and for Equifax and all those other companies. So really the only administration on your part is deciding who to use and trying to cost out the budget for all of that. By the way, the expense can be prohibitive depending upon how many certificates you need. You might just have to cough up the dollars, but let's just take a look at an example. And it's worth it. I mean, the security is good there, but you just have to be prepared for the budget item there. And if I go to, for example, VeriSigns, where we can use a digital ID enrollment here, you can buy for $14.95 per year certificates that you can use to authenticate things such as your email address so that you can verify that your email is secure. Well, that would be $14.95 a month per user. Now, I'm sure that if you wanted to buy several thousand, that VeriSign would cut you a break on price. Nevertheless, that's something to think about there. However, it might pay off pretty well because the liability will be all theirs as well if something goes wrong with their certificates or if something's been mismanaged on one of their CAs. Whereas with an internal CA, you're going to get off with a lot more liability of your own there, and I'll start at the bottom on that one. A lot more liability on your own because if you goof up a CA somehow where you accidentally unloose a private certificate or a private key, or you otherwise compromise your own CA unknowingly somehow, or even neglectfully, well then you have a big liability potentially, maybe with your business partners or other people who are depending upon you to be secure, or with the contract that you had with a vendor that said that you have to have a good secure CA, and if you let that out in the open, or if you make an insecure CA, then your contract is terminated. So you can see there's all kinds of different things there in terms of an internal CA that you have to be very, very careful about. But otherwise, internal CAs are generally used for private or limited use. If I just want to issue certificates to my users so that they can use EFS internally within my company, or so that they can verify that signatures for each other's email to make sure that the email did indeed come from who we think it came from within our organization, that kind of thing. Also, it's going to be a company PKI. It's not going to be a public PKI. It's going to be something that we install on our own servers internally, and we will also have to manually install certificates to any external parties. Maybe we can't justify the expense or the overhead of going to an external CA, so we just want to install our own certificate authority, and then we just give our vendors access to it from our external parties, and we just instruct them on how to install a couple of certificates here or there. Then we also have the administration that's involved. There can be more administration involved in an internal CA. There's more planning that goes into it. You do probably have to budget things out because there is an additional expense factor. You're going to have more hardware there. But in the long run, it might actually be less expensive than buying a whole bunch of hundreds or thousands of individual certificates from an external CA. So again, that all goes into the planning stages in terms of what your requirements are. And also the administration can be quite heavy in terms of if you have to do a lot of manual approvals of certificates, then you have to issue or deny a whole bunch of certificates, and you might have to do that depending on your company's policy in terms of viewing the user themselves. They may have to stand in front of you, show you a picture ID, and match the picture ID to what they look like. They may have to have a supervisor come in with them. Yes, this is the person that we think they are, and then you issue the certificate. So that might be quite a lot of administration. You might even have to hire an additional person just for the purpose of that kind of thing, especially if you're going to do this in something like a smart card enrollment station, and you have a security officer that issues the certificates on smart cards and things like that. Let's also take a look at a certificate authority's PKI hierarchy. Notice that this is a tiered hierarchy that I have here. And notice that I also have a root CA up here at the top, which then issues certificates to this certificate authority and this certificate authority, which in turn issues certificates to additional certificate authorities down here at the bottom. Now there's only one certificate in this whole infrastructure that is self-signed, and that would be the one up at the top, the root CA. And that's because it didn't receive a certificate from some other source higher up in the hierarchy. This is the root of the certificate authority, so therefore it had to self-sign the first certificate that was issued. The root CA in most infrastructures will also typically be stand-alone certificate authority. And again, that has to do with the fact that we want to secure it from Active Directory exploits, or if this gets compromised, the certificate authority gets compromised, we don't want to potentially also compromise Active Directory in turn. So then, once we have our self-signed certificate here, then we can issue additional certificates to subordinate CAs, which would be maybe at this intermediate level CA, and this is a common hierarchy that we have listed here. And then once the root CA issues a certificate to this certification authority, for example, then it will in turn be able to create its own certificates and issue those to its child CAs down here, which might be our issuing CAs. And what ultimately happens then is any certificates that these bottom level certificate authorities issue, we know that as long as whoever receives that certificate, in this case whichever computer receives that certificate, that computer, so to speak, can know that, it can trust the certificate if it also trusts the root CA. So if the computer has a certificate for this root CA, then it says, oh, I can follow the chain of trust. I see that you received your certificate authority, your certificate, from this certificate authority, and this certificate authority received its certificate from the root CA, which I trust. Therefore, I trust the entire path of trusts. Now also, these intermediate CAs will typically also be standalone certificate authorities. However, beneath that, where we start with our issuing CAs down here, these are typically going to be enterprise certificate authorities. Why? Because, for example, for these user certificates, we want to be able to issue certificates using probably auto-enrollment, and that's only supported with enterprise CAs. And because of auto-enrollment capabilities with Active Directory, then we can have users automatically just log on and just automatically receive certificates for their email or for their EFS purposes or any logon purposes like that. Now, we would have to manually enroll smart cards. However, most of the common purposes would be automatically enrolled. Also, for these computers over here, for the computer certificates that are issued down here, these would be also susceptible, or rather beneficiaries of auto-enrollment. You basically just start the computer up, and after a short period of time, it'll receive the certificate without any administration from the administrator. And it's able to do that for both the users and the computers because when they authenticate themselves against Active Directory, then they'll have permission through a policy to also download or to get a certificate from their certificate authorities. So also note that these are the certificate authorities that we have down here, and they in turn issue them to my user accounts and to my computer accounts. And these are my actual clients, my users and my computers down here that receive these certificates. Now let me also point another thing out here. I kind of made these intermediate CAs distinguishable in terms of the kind of certificates that they issue, computer certificates as opposed to user certificates. That's just one idea. You can also do this. People have different ways of doing this. They might also do it according to geography. North America here, and instead of this one, it'll be South America here. And then these issuing CAs might issue both user and computer certificates down in the issuing CAs for South America, and the North America issuing CAs would also issue both user and computer certificates. So it just depends upon the hierarchy you want to establish. Now, why do we also break it out like this? Why don't we just have one CA and set that one up to issue all of the certificates? Well, what happens if this one CA gets compromised? Well, then all of the hundreds or even thousands of certificates that it's issued are also compromised, and we have to start all over from scratch. That's a disaster, so we don't want that to happen. By breaking this out into a hierarchy, we can hopefully do damage control. So that if, for example, someone is able to compromise a certificate over here on this certificate authority, then we suspect this certificate authority is no longer any good. We can decommission it, regenerate our keys, and then we can reissue the certificates, just the ones that were issued originally from this CA. That doesn't affect this CA, doesn't affect this CA or this CA or anything else in my entire hierarchy. So it does damage control by breaking it out like this. Now, another important issue here is for security purposes, you need to take the intermediate CAs and the root CAs offline after they have issued their appropriate certificates. So once this root CA, for example, has issued certificates to this intermediate CA, and this intermediate CA has issued its certificates to these CAs, then I can take this root CA offline and this intermediate CA offline. That's another reason, by the way, that these have to be standalone CAs for those security purposes. Because if these are enterprise CAs, then these CAs down here will not be able to verify their chain of trust all the way up through. But if they're standalone CAs, then it's okay for these to be offline and for the chain of trust to still be valid down here on the enterprise CA. Now let's talk also about how we actually go about the business of taking them offline. And here's how we're going to protect those certificate authorities. One of the first ways I can do that is to make it a workgroup membership instead of adding the system to the domain. And that would be sensible in any case because, I mean, after all, if it's a standalone CA, it doesn't use or need Active Directory, so why make it a member of the domain? For one thing, I might have in the past generally used group policy objects to manage my servers. But if I've just got 2 or 3 or 4 or 5 different certificate authorities that are workgroup members, well, I can manage them with local policies, and that wouldn't be too overwhelming of an administrative burden. And then if there's an exploit against Active Directory that could affect my certificate authorities, well, they're isolated from that. On the other hand, if there's an exploit against a certificate authority that could affect Active Directory, well, if they're a workgroup membership, then we're isolating them from Active Directory. So we're helping to partition out their attack surface. There's also a matter of physical removal. You could just put it into a different physical segment or a different network segment that's not directly attached to any other part of your network or not attached to the internet or anything like that. So I want to just physically remove it from the network. You could also, if you want to double up on services, you don't want to have the expense of simply powering off a server, you could just stop the service. Maybe you have a server that has 2 roles. It's a certificate authority, plus it's also a file and print server, plus it's also some other kind of a server. Well, you can have it do both those roles, and yet after it's issued any of the certificates it needs to its subordinate CAs or to its intermediate CAs, then you can just stop that one service, the certificate authority service. And that effectively brings the certificate authority offline while it continues to provide service to whatever else it needs to do. That way you don't have the asset just sitting around doing nothing if you powered it off. By the way, for powering it off, there's another way you can economize on that if you do have a high physical requirement of just powering off the system entirely and not even doubling up on the services. One thing you could do is to install your server, your Windows Server 2003 server, install certificate authority on it, and then once you've issued the certificates necessary, you can just pull the hard drive out of that server. And then you can install a different hard drive in that same server and make it your Exchange server, your file server, whatever other kind of a server it needs to be. And that way, at least you're not wasting all of that asset. You're just removing that one hard drive. And then if something comes up where you do need that certificate authority back, then you gently power down and shut down gracefully whatever that server is currently doing. Put your CA hard drive back in there and issue your certificates, and then pull it back off again. So that's just another option that you might consider in terms of powering off a server. And then also, wherever you put it, make sure that you get it high physical security so that you only have a secure access to the physical location where that certificate authority is. In this nugget, we took a look at certificate authorities, and we saw that there are several different uses for certificate authorities in a PKI infrastructure. PKI being public key infrastructure, where we use certificates and public keys and private keys. And we take a look at those certificates and keys and how they're implemented in this nugget as well. Then we also took a look at the various types of CAs that are involved. You might have standalone CAs, enterprise CAs, internal, external CAs, different kinds of CAs within your hierarchy, which is normally going to be a tiered hierarchy. One important part of that is the top levels of your hierarchy are typically standalone CAs, and you also need to typically protect those CAs by probably taking them offline, and you can do that in a number of different ways that I showed you. I hope this has been informative for you, and I'd like to thank you for viewing.